Okay, is my screen visible?
Yes, sir.
Okay, so this is the first problem of division 2. So in this problem, we are given that we have two integers n and m and a set containing all the integers from 1 to n. So all the natural numbers from 1 to n. So then we are also given a set Q of size m, and it is a subset of set S. That means it also has numbers from 1 to n, but it doesn't have all the numbers from 1 to n. It has some of those numbers. And finally, we are required to convert S into Q after using the following operations. What are the operations? We can select an integer k and such that there exists a multiple of k in S. We can remove the smallest multiple of k from S. And finally, the cost that this operation will incur is k. So after doing like some X amounts of these operations, we'll have a final cost, right? So let's say our cost, there can be multiple, like we can achieve S from Q using many like different operations. So we'll have different costs, but we have to find what is the maximum cost. So let's look at this problem here. So actually this problem is quite simple. Initially, I have a set S which has 1, 2, all the way till n. And then, okay, so meanwhile, if like you can write in the chat whether you were able or you were not able to solve this problem during the contest, like all the students. And we have another set Q, which is a subset of this. So we can have something like 2, 3, 7, all the way till n. Like maybe there is an n, maybe there is not an n in our Q. So what we are asked to do is we have to remove, let's say we have to remove 4 from this set to in order because to get this set, right? Because there is no 4 in Q. So we can select k such that we can select 2, right? Because 4 is a multiple of 2 and we'll have 2 as our cost added to our total cost. So this way we'll have to remove each of the n minus m elements from this array to convert it to this, and while removing each of the elements, I'll add the cost corresponding to the k that I chose. Okay, I think majority of the people were able to solve this problem, so I'm not going to waste much time on this. So now, if I have, like this is the cost, so the observation here is we'll never choose, like if I'm trying to remove some x, I'll always choose x. Because what is the maximum divisor of x? What is the maximum number that divides x? It's nothing but the x itself, right? So this is the other way looking at what is the maximum k I can choose to remove this number. It's x itself. So just count, just find which all elements you have to remove and add those. That's your final answer. So is anyone having any doubt in this, the approach? Yes, no, anything? Or is it clear? Okay, it's clear. Like you can unmute yourself and let me know in case you have any, in case you feel like you have any doubt. So how to implement this? One of the ways to implement this is like either you can actually go iterate through your arrays and find, okay, which all elements are missing and add those. But one of the simple ways to do this is just like, what is the sum of natural numbers from 1 to n? It's nothing but n into n plus 1 by 2, right? So all the, like the sum of all the elements present in my set S, this is the sum, and find the sum of array A. So let's call this as sum A, and let's call this as total value. So I can simply output total minus sum A, right? Is this clear? Yes, no, anything?
Yes, sir.
Okay. So let's just quickly look at the implementation once. Okay, so this is the implementation. In this, I have first taken my n and m as input, then I'm taking my array A as input. Finally, sum A is the sum of all the elements present in my array A, and the total is n into n plus 1 by 2. That this is nothing but the sum of the first n natural numbers. So finally, my answer is total minus sum A. So I don't think anyone is having any doubt in this. Let's move to the second problem. So this is the second problem. In this problem, I'm given an array A which has n integers, and I can choose indices I and j such that the absolute difference between these two indices, the selected indices, is at least k. Like it should be more than or equals to k, the difference between the two selected indices. Finally, if this condition holds, I can swap these two integers at ith and jth positions. So I have to find what is the lexicographically smallest array. That means out of all the permutations that are achievable using these operations, what is the smallest array lexicographically that I can achieve? So how many of you were able to solve this problem during the contest? Okay, like, actually I'm asking you this because like I'll get an idea how much time I need to spend on this. If majority of the people were able to solve it, or if like everyone has a fairly decent idea what the problem is asking and how to approach it, so I won't invest that much time in it. Okay, so there were people who couldn't solve this problem, right? Okay, so now let's look at, suppose this is the array that is given to me, and I have a k selected. So what does this k mean? Like it's also mentioned in the problem. This is nothing but like my selected indices should be at least k distant from each other. Like they should be at least having a k distance from each other. So if my k is 3, I can select this value and this value, right? If my j is this, my I can be this or anything after this. So what does this mean? This means, okay, let's look at, let's say how many numbers can I swap with this number? I have all these choices, right? And how many options do I have with this number? Let's look at the endpoints, not anything in between, but just let's look at the endpoints. So if I can swap all these elements, and from with this element 1, 2, 3. So with that element, I can swap all these elements, right? I can swap all of these elements with my last element and all of these elements with these elements. Is this clear? Like if my k is 3, or is like if anyone is having doubt in this itself, let me know at this point, because there is no point in looking like what is going to happen next if you are confused how I came up with this. Okay, it's clear. So now let's look at one thing. Can you actually make this the element which is present at this position? Can you make this element go to this position? Yes or no? I just want yes or no. Can you actually make this element come to this position? I don't know. I'm not worrying about any other elements. I don't care what their position is. I'm just asking you, can this element finally end up at this position or not?
Yes.
Okay, it can. Can it end up at this position?
Yes.
Okay. Can it, like I'm going to explain you how also, but right now I'm just asking you, can it end up at this position after some sequence of swaps?
Yes.
Okay, so I'm gonna tell you like it can end up at all of these positions. Now let me tell you how. Like this is clear, right? This can simply be swapped with this position and finally it will end up at this position, because I'm saying that this element can be swapped with any of the elements that occur in this part. So now how come this element can come here? See, this element can actually come here in first swap, right? In second swap, I'll make it come here at the first position, and then it can come to any of these places. So by default, any of these places can, like this element can come to any of these places. Now, what about these? Like this is originally here, so let's also take this position, and I can also bring it here, right? So how to bring this element here? How to bring this element here? Okay, I just told you that this element in one move can be brought to this place, and then this element can actually be swapped with any of these places, right? So it can also be brought to this place. So this element can actually be brought to any of these places after some sequence of swaps. Is anyone having any doubt? Yes, no, anything? Okay, no one is having any doubt. So now this was just for a fixed k and a fixed n. But the key takeaway point from this is for a selected value of n and k, there will be, okay, now let's select another k, like it will be easier to prove. So let's say that my k is, right now it's, let's say my n is 1 2 3 4 5 6 7 8 9 10, and my k is 8. So if this is 0, like I can only swap this element with elements that are present here, right? Right, or like, is this making sense? If my n is 10 and k is 8, I can only swap this element with these two elements. Okay, this makes sense. And I can swap this. Yes.
Why not you can't swap with eighth element? It is
Like,
given that I minus j greater than or equals to 8, right?
okay. This is your 8th element. You're using one indexing.
Yes.
Okay, so this is your first element.
Okay.
So 8 minus 1 is 7, not. So this is 7 is less than, like the absolute value of this is less than your k.
Okay, got that.
So now this element can be swapped with these two elements, and this element can be swapped with these two elements. So I'm not going to like actually tell you about this element, because this element can also only come here. So now what my point is, now if you look at these 4 elements, if you select any of these 4 elements, you can like have their final positions at any of these 4 locations. Other than for these elements, you cannot swap any of these elements, you cannot change any of their positions. But for the 2 elements or the 4 elements, 2 from here and 2 from here, you can have them anyway in one of these 4 positions. Like this element can end up either here, 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 or here. Like how, okay, let's see, like let's actually visualize what is happening for one of the elements. Like, okay, how can this element end up at this place? Just swap it with this element and then bring it here, right? So this is taken, this is done. Now how to bring it here? How to bring this element here? This is okay, but how to bring it here?
After bringing to first position, we can bring that to ninth position.
Yeah. Yes. So first bring this here, then bring it to the first position, and then bring it to this position. So this element can also be brought to this position. So this way, any of the 4 elements that are present in these 4 locations can be brought to any of these 4 locations. So what I'm trying to say is, now simply put, suppose you have an array A. First find what is the maximum, like what is the range that you can have for this element. Then find what is the range that this element can be swapped with. In case these 2 ranges swap, it means that simply you can take the complete array. Or if these 2 ranges don't swap, like don't actually, like they don't merge, or they don't have something in common, then you have something like this. So simply add these elements to a vector, sort your vector, and place your elements in sorted order in these positions. Like just swap these 6 elements and order your elements in increasing order in these 6 positions, because you don't have any control over these elements. You cannot swap these elements with any other position. And I have proved to you, like I have given you the intuition that these elements can be actually brought to any other positions. So is it clear?
Sir, what if the ranges are collide each other? I mean,
Okay, if any with like, okay, if the ranges are like this, okay, the first element can be swapped, like the last element can be swapped from anywhere from here to here, and the first element can be swapped from anywhere to here to here, then you simply mean that you can take the complete range, right? You can swap any of the elements, like you can have any element at any position.
okay, sir. Once
You have
explain.
you have more control, right? This meant that this range meant that these elements can only be brought to the last position. This meant that these elements can be brought to the first position. If it's coming in both of these ranges, it simply means that you have more control over that element, right?
Okay, sir.
So if this is clear, I'll move to the implementation part. It's clear, right?
Yeah, sir, it's clear.
Okay. Like I only hear one of the students speaking. What about others? Okay, some of you are writing in the chat, but speak up, okay? Otherwise, I might miss up whatever you wrote in the chat. So this is the implementation. So first, I'm taking n and k as input. So if k is more than n, then anyway you cannot have any swap. Like there are no 2 elements that you can select in order to swap them, right? So simply output a vector a. Otherwise, I've initialized, I've declared a vector v, and in this vector I'm checking if I is less than k. That means this element can be swapped with the last element which is at the last position, or if n minus I minus 1 is less than k. So this is simply those elements that can be swapped with the elements at the first, that is at the first index. So if none of this is true, I'll simply continue. That means my element is somewhere in between. Otherwise, I'll push this element in my vector. If either a is less than k, if I like is less than k, if more than k, like if it's more than k, or if this is also more than k. If any of these is true, while less than k, okay. See, if I is more than k, then this means that from the first index to, okay, you got it right. Okay, let me complete. So from the first index, if you find the absolute difference of this first index, like of this element from the first index, it will be actually more than or equals to k, because I is more than equals to k. So that's why you can actually swap this element with the first element, and similar thing goes on with this. So if none of these is like, if both of these is true, that means you are somewhere in between and you cannot actually swap this element with any of the first or the last element. And anyway, like if you are not able to swap this element with any of the first or the last element, that are like either the first element or the last element is going to be at maximum distance from any of the elements in the array, right? So if you're not able to swap this current element with the first element or the last element, you cannot swap it with any other element. So you can simply continue. Otherwise, push this element in my vector. I'm pushing this element in my vector. Finally, I'm sorting my vector. And once this vector is sorted, I'm reinitializing my array values in these ranges according to my sorted values. So it's clear, right? Yes, no.
Yes, it's clear.
Okay, so let's move to the next problem. So this is the next problem. In this problem, we're given an array A of n non-negative integers, and we have to create an array B that is formed by first, while the array A is not empty, I'll choose an integer k. Now, then I'll choose some k elements from my array A and I'll find the max of them. So whatever the max of these k elements is, I'll add that to my. Okay, someone wrote -1. What is this -1? Okay, you were not able to solve this problem during the contest, right? Okay, fine. So then you append this max value, the max of these k elements, to your array B and erase those k elements from your array A. So finally, you will get an array B, right? So you have to find what is the lexicographically maximum array B possible. So actually, this problem has nothing, just implementation and nothing. You don't have to use any algorithm. Like it's like the last problem, nothing, like no algorithm, nothing. So let's say I have some values. So what is like I'll try to get, since I have to find the lexicographically maximal array B, I'll try to have the maximum value that I can achieve for my first position. Is this clear? Is this clear?
Yes.
Like, okay. So now how to get the maximum value? First, I'll try, is my max equals to 1 possible or not? So for my max equals to 1, what element should be there in my array A? Like what element there should be? Like I have to choose k
0.
elements, right? There should be a 0. Now there is a 0. Okay, I have checked. Somehow I have checked. I have removed it from my array A. Let's not discuss what data structure I'm using right now, but let's say I removed it in some O of n log n or something, and now I'll check, okay, is 1 present in my array? Because if 1 is present in my array, I can remove that 1 also and my max will be 2. So now this way I'll keep checking till my max is available in my array A. I'll keep removing those occurrences from my array A. And finally, when I find, okay, this max is no more available to me in my array, I'll add this max to my vector B or array B. Is this making sense?
Means that the value which I am not getting, then I'll add that.
Yes.
Means from 0 we are starting, and
You
after
start
that the value which we are not getting.
Yes.
Okay.
Also, one more thing. If like, okay, let's not get into the implementation part. First of all, is this clear?
Sir, once explain from the beginning.
Okay, I'm saying you'll try to add the maximum element to your vector B, which is possible, right?
Yes, sir.
Okay, so first check whether max, like, can you add 0? If you're starting at starting, your max is 0. So you'll check, okay, if your 0 is actually available in the array, your max will become, if you select that element, your max will become 1, right? Because just you select that element. So
yes,
you check that, okay, you have a 0 in your array, you remove that 0, there can be multiple zeros, and these zeros will be like, don't remove all of these zeros at once. Why? I have an option that, okay, for the first time, I had something like 0 0 0 1 1 1. So what is the max that I can have for the first step? Maximum. What is the max?
0. 2.
Who said 0?
No, sir. 2.
Okay, so it's 2, right? So 2 is because I can select 0 and 1. So after I select these two elements, I have like k is equals to 2, and I have these two elements selected. My max of this set is 2. So there is like there is a possibility that I can remove all of these elements, select all of these elements, and max of this is going to be 2. So but this is not beneficial, like this is not the optimal solution, right? Why?
Because I might be getting 2, 3 afterward.
No, I'm not going to get 3, but yeah, in other case I can get, yes, in other case I can get, but in this case, if I remove just 0 and 1, I get 2. Another, like in second operation, I'll again remove 0 and 1, I again get 2. Then again, I'll remove 0 and 1. I'll again get 2. So 2, 2, 2 is lexicographically more than just 2. Okay. So what I have to do, I'll simply check, okay, if starting from 0, if I have 0, like this max value in my array A, if there is an occurrence of this value in my array A, I'll remove that occurrence from my array A, then I'll increase my max by 1. Then
Hello?
I'll again, yes.
What if 0 is not present in the array?
Yes. I'm going to, like, this is actually an implementation detail, so I'm going to discuss this in a bit moment. But is this like, first, let's make this thing clear that what we'll do. So then I'll increment my max by 1. I'll again check in my array A. If I find that, okay, now this element is not present in my array A, I'll simply push this value in my vector B. So till now, everything is clear, right?
Yes.
Okay. Now, coming to the point that my array A now doesn't contain any zeros. It has something like 1, 1, 1, 2, 3. So anyway, I cannot have anything more than max equals to 0. Why? Because for
I think that then 4 times 0 will.
yes, because either I can remove all of these elements at once, and suppose my array of B was something like 2, 2, 1. I'll have 2, 2, 1, 0. But if I remove them one by one, and I'll get 4 zeros. Right, so my array will be 2, 2, 1, 0, 0, 0. And in the problem statement, it's mentioned that if an array A is coming in the prefix of some other array, then it's lexicographically smaller than this array. So that's why my final answer is going to be this. Is this case clear? If I don't have any zeros, just push these many 4 zeros. If I had 4 elements in my array, just push 4 elements in your vector or array B. Is this clear?
And what if all the values are 0?
All the values are 0. So like, you tell me. Okay, my max is
Then
0.
all 1.
I'm checking max equals to, is 0 available in my array?
Yes.
Okay, so I remove one occurrence. Now my max is 1. Is 1 available in my array?
No.
So I'll put this in my B. B is now 1. Again, for the second step, 0. Is 0 available in my array?
Yes.
Then 1. Is 1 available in my array?
No.
So 1. So for all of these, you will continue and you will have 1, 1. Is this clear?
Actually, I understood the same concept during the concept, but I could not implement it. I was getting MLE, memory limit exceeded, because I could not understand which data structure to use.
Okay, so which data structure do you think which has multiple, like which can hold multiple occurrences of an element, and I can remove them in probably
Multiset.
Yes, multiset. So use multiset. So let's look at the implementation ones. Probably things will get more clear then. So this is the implementation. In this, first I'm taking my array A as input. Then I have declared a multiset. In this multiset, I have inserted all the elements of my array A. Then while my multisets, there are some elements in my multiset, some elements are remaining in my multiset, and the starting value is 0. Why? Because if the starting value is not 0, that means I have removed all the zeros. So then I'll simply do my max is 0, while max mst.find, that is my multiset.find, max is not equals to end. That means my max is appearing in my multiset. So I'll erase one of the occurrences. Now keep in mind, don't do mst.erase max. That will remove all the occurrences of max. I just have to remove one of the occurrences of max, and then I'll increment my max. Finally, once this loop gets terminated, I'll insert this max in my answer. So finally, when this loop gets terminated, either one of these conditions is false. So either all the elements have been removed, that means the multiset size is 0, or the beginning, the lowest element in my multiset is no longer 0. So if the second condition is true, I'm iterating from 0 to multiset size, and I'm inserting those many zeros in my answer vector. Finally, I can print my answer vector size and my answer vector itself. So is this clear?
Sir, can you explain with an example then?
Hello?
Yes.
It is clear, and the time complexity will be n log n.
Yes.
Okay.
Sir, can you explain the test cases once?
Which test case?
First and second.
Okay, first and second.
Yeah.
Great. Like if, like probably if you're having like further doubts, I think it will be better if you mark, like raise a query and tag me in it, because right now it will, like I don't think is anyone else having any doubt? Like is anyone else want me to discuss those test cases? Like either write in the chat or let me know. Because if many people are facing the same doubt, I think I should go over it. But if only one is, like one of the students is facing that out, it's better that we'll cover it over a query. So is anyone else having any doubt in this problem?
No.
Okay, yes, no, anything. Okay, like every one of you, like, okay, I'm getting some no's in the chat. Like each one of you write something in the chat. Just let me know whether you want further explanation or not. Okay, it's clear. So I think, like, who asked me this doubt? Who was having? Like,
Okay, sir. I will make a query on that.
If I invest more time in this, it will probably lead to more time wastage of like other students, right?
Okay,
Moving
sir.
over
I
to-
will raise a query on that.
I'll surely get back to you. Just tag me in that query, okay?
Okay, sir.
Okay. So let's move to the fourth problem, and this is the last one that I'm going to discuss. So the problem is this absolute differences. Actually, I think in division 2, more people were able to solve that zero. I don't remember that problem name, but something zero. So actually,
Zero.
yes, one of my test cases were failing, and I haven't actually submitted that problem after the contest. So I'm not going to discuss it because during the contest, my solution didn't pass all the test cases. One of them was failing. So let's look at this problem. Like this problem, like sometimes you see in the leaderboard that okay, this problem has less number of solutions, and you feel that okay, this is a hard problem. Believe me, this is not a hard problem. This is basic problem, and in this problem, we are given integers from, like, I think, okay, let's not make a conclusion that this was easier or harder than other problems. But for me, like, I read this problem and like I didn't have to even think about the solution. So in this problem, we are given an array A of integers between minus 10 to the, like, I'm not sure why this is mentioned here, because later on it's written that the values that are given to me are between 10 to the power 9 and minus 10 to the power 9. And the differences also is between 10 to the power 9. So I'm not sure how like this actually matters, or is this actually true? But anyway, we are given an array A of an integers. So each of these numbers is said to be between minus 10 to the power 100 and 10 to the power 100. So then all the array elements are initially unknown to us. Then Alice and Bob gives us some gives us some constraints regarding what all these numbers can be, and we have to find whether or not their constraints are consistent or not. So what Alice gives us, like Alice gives us m pieces of information, and in these information she gives us that okay, at this position there is this value. So she gives us a sure shot value that at this position there is definitely this value. And what Bob gives us that there are two indices u and v, and the absolute difference between the values at u and v, at these indices, is less than or equals to d. So finally, after looking at pieces of information that Alice gave us and k pieces of information that Bob gave us, we have to find whether or not these are consistent. Like, okay, so what does this mean by consistent? Let's first clear out the problem. Like, what is problem statement asking us to do? See, if we said that, okay, we had three elements, and Alice said that at first element, element is 5, and at the second element and the third position the element is 100. This is what Alice gave us. Okay, and then Bob gave us that the difference, the absolute difference between the first and the second element is less than or equals to, let's say, 5, and the absolute difference between the second and third position is less than equals to 5. So can you actually, is this consistent? Is this thing consistent or not? I'm asking you. Do you think that this is consistent? Can you actually make up an array if you had enough information? What is the element that is going to be in between? You cannot come up with any element, because this tells me that this element can maximum be 10, right? And this tells me that this element at least needs to be 95. Is this thing clear? Like what consistent means, and this is not a consistent array. If I would have something like 10 here, then I could have gotten a consistent array. So then the information would have been consistent. So it's clear, right? What consistent means. Yes or no?
Yes.
Okay. So now let's look at, okay, first I'm given m type of m pieces of information, which are that this, like some positions are having this value, some position is having this value, like what value is at this position, what value is at this position, what value is at this position, right? And then I have, let's consider other k pieces of information as edges. Like this is somehow related to this position, this is somehow related to this position. And now you can see the constraints for k. What are the constraints? Like what is the maximum value that k can have is 3000. And what is the maximum value that n can have? It's, I think it's 2000. Yes, it's 2000. So if you make a cycle, like what is the maximum length of these relations that finally that, okay, this went from here to here, this went from here to here, this went from here to here, like these are the relations, the arrows that I'm drawing, and this finally came to here. What is the maximum length of these relations that I can have? It's n, right? After n, because either before n or like before n, or at least after, like at max at n, I'll end up at, if there exists a chain, I'll end up at this very position. So this means that I go from here to here, then I go from here to here, then go from here to here. So these are all the relations. So if all these relations satisfy and I come back to this position and all of these conditions satisfy, then it's consistent. But otherwise, if at any position I find out that, okay, this is not consistent, like this demanded that the integer should be between 5 to 10, and this is saying that the integer is between 100 and 95. So this is not consistent, right? Otherwise, if this would have said that the integers should have been between some 8 and 10, and this is saying it should be between 5 and 10, then I can have a mutually intersection of these two ranges, and I'll say that the integers should be between 8 and 10. Then it's consistent. Like, okay, there is something that both of these indexes have, that this piece of information abides by these values, right? There is some value that this piece of information follows. Otherwise, if this piece of information is telling me that, okay, that like some told me that, okay, this 5, like the element here is 5 and 10, and the others told me that, okay, the element here is 10 and 95, and finally I had something like the difference between these two elements should be at max 2. Then I can never have this consistency, right? So let's not get confused. What I'm trying to say, that we have at max n length chain. So okay, now let's look at, so I have some chains. Okay, let's not get into graphs directly, but do you people actually know about Bellman-Ford? What Bellman-Ford is? How many of you know what Bellman-Ford algorithm does and what it is used for? Write in the chat. Okay, some people have idea. So what Bellman-Ford is an algorithm just like calculating shortest distances. And this, the complexity of this algorithm is V n into m. Okay, it's not actually n into m, it's something like O of V plus E into V. So V here is the number of vertices, E here is the number of edges. So what we do in this algorithm is, suppose we have a graph like this. Suppose we have a graph like this. We make n iterations over this graph, and initially this vertex, the starting vertex, has the value 0. Suppose this is the starting point, and each of the other vertices have distance marked as infinite. And then we make n iterations over complete, like through this graph, and each time if like from u to v there is a vertex and distance from u, like let's say this is the cost, if the final distance or final cost of this is more than the final distance or cost of this vertex plus c, then we'll update this. So this way, after n iterations, we make sure that for each of these nodes we have the lowest distances achievable if we start from this starting node. So this same very logic I'll apply in this problem. So I'll iterate over my graph n times. I have starting from those positions which I surely know that this is the value. Like Alice told me that these are the positions. Let's say this is position 1, this is position 2, this is position 3, and this had some val 1, this had some val 2, this had some val 3. So now this is given to me by Alice. So I'll start from these positions, these vertices, and I'll try to move. Like how did I get this relationship? This is nothing but what Bob told me. Let's say this is U, this is V, and there's some constraint like U, V, and D, right? So there is some constraint that the value that is going to end up here should be like the value here and here should have at max D difference, absolute D difference, right? U, A of U minus A of V should be less than equals to D. This is given to me in the problem statement, right? Just let me check. Yes. So this is one of the relationships between position U and position V. So now what I can do is I can simply initially, like for each of the positions, I have something called maximum possible value and minimum possible value. So for all the positions, maximum possible value, let's say it's something like very big, like 10 to the power 12 maybe, and it's minus 10 to the power 12. Okay, then after, or let's say it's 10 to the power 18, because I have 10 to the power 9, and I think 10 to the power 9, 10, 11, 12, yeah, it can be more than 10 to the power 12. So let's say that it's 10 to the power 18 and minus 10 to the power 18. It cannot be more than or less than these values, definitely. So, okay, just wait. Okay, m is 0, m can also be 0. So there is a possibility that these values can be less than, or if like actually Alice didn't give me anything, then it's possible that these values go up till 10 to the power 100. Because Alice never told me anything that what is one of these values. And when Alice tells me that, okay, one of the starting positions is this, then only I have something to have these maximum and minimum positions, like a fixed value for these positions. Like this position will have a fixed value as this. So, okay, let's not get into that. But what I'm saying, like initially for each index I, my minimum position and maximum position are these. If there is a, like if Alice told me that, okay, at position U, I have value, then I'll simply do maximum at this maximum possible value at this position is equals to minimum possible value at this position is equals to val. Because Alice has definitely told me that at this position, this is the value. So maximum and minimum, there's only one possible value. Otherwise, there is a range, like everything is possible between this, and these values are possible for this current I. Now what I'll do, I'll simply iterate over my complete graph n times, and I'll start from those positions whose value is definitely known to me, and I'll follow these relationships and I'll try to update these relationships. How? I'll check, okay, this has some, let's say this has some range L to R right now, and I have my D here, and let's say this is X to Y. Now, X is going to be maximum of X comma what? What should come here? This should be L minus D. Okay, I'll show you how this came. Y is going to be minimum of, okay, this is Y R my plus D. So how did this came? See X minus, if I chose L here, so that meant my X minus L, the mod of this value should be less than equals to D, right? So X minus L should be between minus D and D. So X should be less than, if this comes this side, L plus D, less than or equals to. That's why X is maximum of either L minus D. X cannot be more than L plus D. Okay, this is, if L comes this side, then it will be L minus D, right? If L comes to the left side, not to the right, like if L comes to the right side, then X should be more than, this is other condition, but actually we don't have to consider this condition because it's taken care in Y. So if X should be more than or equals to L minus D, this means X should be maximum of whichever value X was initially, or L minus D. And similarly, my Y minus, Y is the value here, like my Y minus, let me change this. My Y minus R is, the value of this mod should be less than equals to D. Y minus R should be between D and minus D. So now Y should be less than, R comes to this side. Now, last time I took it to the left side, right? I'm taking it to the right side now. So Y should be less than R plus D, less than equals to, so that's why Y is minimum of Y comma R plus D. So this way, for each of these relationships, I'll have the modified ranges for each of my positions, and I'll check if at any instance my minimum, like my left, that is the starting point of this range, is more than the ending point of this range. That means this is not possible. So at that point, I can simply break through my iterations and I'll simply print no, because then this is not consistent. So is this making sense? Is this clear? I know like this is a bit hectic, but like the intuition will be much more clear when you actually see the code, the implementation. So it should be, so first I'm taking my n, and k as input. Then I'm initialized my min, min. This is minimum possible values for n, for all the n positions, and this is max is maximum possible values for all the n positions. So initially max, all the maximum possible values are 1e18, that is 10 to the power 18, and the minimum values are minus 10 to the power 18. So f is 1, f is nothing but a flag. Like if f is 1, then answer is yes, otherwise it's no. So now this is a graph. So the first of these is the value, not the value, but the position. I think, yes, it's the position. And the second one is the actual D, that is the difference, absolute difference. So first of all, for taking the pieces of information from ELIS, I'm inputting two things, that is position and value. So since the positions are given to me as 1 indexed, I'm decreasing my position by 1 to get them as 0 indexed. Then if my minimum at this position was more than value, and or maximum at this position was less than value, then initially only my answer is not possible. It's not consistent. Otherwise, I'll push this position in my starting ST. ST is nothing but it acts as a starting possibilities for my iterations. So otherwise my minimum possibility is equals to maximum possibility for this position, it's value, minimum and maximum possibilities. Then I'm taking k pieces of information from Bob. So Bob gives me u, v, and d. Since these indices are one indexed, I have decreased my u and v by 1. Then I'm inserting these indices or this piece of information in my VA as a graph. So I have added an edge from index u to index v, and this d is nothing but that the difference between these, absolute difference between these two positions should be d. Then finally, I have taken a visited array for having n iterations and a queue. So this is nothing but this is just for iterating, like this is a variable here. Don't get confused. And I'm iterating n times. And I am checking that my flag should be 1. If it's not possible, then I'll not continue. So first of all, for each of the iterations, I'll mark my all the visited values as 0. Then I'll insert these values, all the starting, like ST was nothing but ST holds the starting possible nodes or the indices that Alice gave me, whose value is definitely known to me. I'll insert those indices in my queue. Why start from these? Because these are those vertices whose value is definitely known to me. So I'll insert these values in my queue and mark them as visited. Then while my queue has size and flag is 1, I'll take the first value from my queue and I'll iterate over all of its neighbors or all of the indices that have some relationship with this index. Then I'll update their minimum v, that is the minimum possible value at index v and maximum possible value at index v. So this is how I did it. So this was explained a little bit earlier, that minimum v is maximum of minimum v, comma, minimum of e. E is nothing but current. If you see here, e is nothing but current index. So we are like generally accustomed to marking this as u, but this is e here. It's like we take generally u and v, but I have taken e and v. So minimum min is minimum possible value at e minus d. And similarly, max, maximum possible value at v is calculated. So f is, my flag will be 0 if this is false. That means my minimum possible value at v is more than the maximum possible value at v. Finally, if the current node was not visited, that means it has not been inserted in my queue till now at least once, I'll insert it in my queue. And I'll keep continuing this n times. Finally, once this loop gets terminated, I'll simply check if my f is still 1, I'll output yes, otherwise I'll output no. So is it clear? Okay, yeah, you can tag me. No, like, no need to be sorry. This problem is actually like, maybe if you have not solved like these ranges kind of problem earlier, this problem might seem a bit difficult to you. No problem. Just raise a query and tag me in it. I'll try to help you the best way I can. Okay. Okay. So.
Yeah, thank
Okay. Yeah. Are you asking me something or is it okay?
you. No, nothing.
Okay. So I think you can stop now. Thanks for joining. Bye.